Okay, so the next two lessons, I intend to work on the analog pins here on the Arduino, and we're going to look at input sensors. So we're going to look at an LDR, or a photoresistor, or a thermistor, or temperature control. Okay, the next two videos. And what I'm going to do for you today is sort of set up two little circuits here. And the one circuit is going to be monitoring the analog pin, okay? So the resistance for this photoresistor. And once it gets to a certain value, it's then going to communicate with this pin here and tell the servo to move, basically. And what I'm looking to do, like I said, I'd mentioned projects to you. Now this could be like a graphics, or you could take it further and you could use materials such as acrylic, metals and wood, or whatnot. And what I would intend to do is make this point of sale, which would have leaflets in it, more interactive. Okay, and by doing that, what I mean is, let's say this firework was separate, and at the back of this point of sale. And whenever this LDR, as you'll see what happens on the circuit I make, is covered by somebody, if somebody stands in front of that, I want to activate this firework to sort of rotate around the back of this point of sale to make it more interactive. So it would go from there and rotate around 180 degrees behind it. Then when the person left or stopped standing in front of this point of sale, it would return back to its original position. Okay, so that's just some idea for a project that you could do. And the circuit that we could build to help us do this would be the circuit I'm going to do here now. So let's get a photoresistor out. This one, okay. So this is a little LDR, a light dependent resistor, okay, and I'm going to put another resistor with it. Let's get this out, and let's put this as a 10K, I think. Let's put a 10K here, and I'll show you what you can do with this later, adjusting it. And we're going to ground that back up. So that's just a little circuit going from positive to ground. Okay, let's change that to black. Okay, now we need to monitor that, and we monitor this circuit here with our analog pin. So let's take that out down to an analog pin here and put it into AO. So that's going to be comparing what's going on in this circuit all the time. Okay, and when it gets to a certain value, I can then tell another pin to come on and operate this. And that's basically what we're doing here. So that works around here, and it's being monitored by this analog pin. Okay. So let's go and wire up our servo. So we've got our ground. Let's bring our ground down here. Let's plug him into ground. There. Make that black. And then we're going to take our power out. Let's plug him into power here. And we'll make that red. Okay, and then we just choose a pin. So let's choose pin 7, take it up here, go into pin 7. Okay, and let's make that green. So now we've got two separate circuits. This is going to be operated on a general input-output pin when I want it to. So I can decide at what light level I operate this. Okay. So there's our circuit made, our two little circuits made. And this one, the difference between this one is it's just receiving a signal to come on from an input-output pin, okay? Whereas this one is being monitored constantly. So, and the difference, and this little circuit here is built into many new cars. So when you see your parents or you drive into a tunnel, your lights will automatically come on because of this component here. And it's like there's a chemical reaction in here, and basically the current can't flow through here the same way as it does when, so let's say we're in daylight, we've said it's in daylight, current is just flowing through. When it gets dark, a chemical reaction happens here, and in a circuit, the current is forced elsewhere, okay? And that's how an LDR circuit works, basically. So let's code this. So all we need to do is, let's put a comment up here. So what are we going to do? So it's going to be a servo activated by an LDR, okay? A light dependent resistor. And then what do we need to do? Well, because we need to know when, so we're going to use an if statement, okay? So if, and in our inputs we've got a read digital pin, okay? Analog pin, not the digital pin. So we need to put our condition in. Let's put our condition in here. So when that, and then we can make up our condition. Let's just set it above, let's do 100 at the moment. Okay, so when that is above 100, wherever the value is, we just want to activate our servo. So rotate that pin. We're on pin 7. Okay, let's rotate it 180 degrees just to start. And if not, rotate it to 0. Okay, let's try that. Now, this defaults to light straight away. Okay, so maybe this moves as soon as we run this simulation, because this is all, defaults to dark. So it's already on dark. So let's see what happens. Yeah, so we get movement there. Excuse me. So what I need to do is click on here and put it to light. Okay, and you'll see that then reset. So you can imagine now that, let's move that out of the way. You can imagine that if we go back to here, nobody's standing in front of this, okay? It may be on a desk with some leaflets in it. No, we can't put leaflets in it, or certainly not that area, because then they would cover the LDR, unless the LDR was forward, of course. So let's say this box, we put our LDR here, okay? When somebody stands in front of that, I want that then to activate. So this is exactly what would happen. So as I go down the range into darkness, you keep your eye on the servo. If I move that down, there, so that servo moves, okay, and then it moves back. You can see that, okay. Now you can decide to move that. At the moment we've got that. If I move that around the other way, let's say 0 and 180 here. Let's see what happens this time. Start simulation. Okay, so it hasn't moved this time. So let's put that down to light. Okay, so now it's that way. So because the other way it was moving, so this way it should move clockwise. There you go. So now imagine the rocket attached to that. It would now move in a clockwise motion. Okay, and you can see that I'm going right down the scale here to get that moving. We can change that by the resistance of this. Okay, so let's put that on 5 for a minute and see what happens. So let's run that simulation again. Let's move that onto light. Now let's see where it was around here. It started moving. So let's see what happens. Now look, very little light, very little coverage of that LDR would take it to move it that way. And a good idea actually would be, you can put fixed resistors like I'm doing here, but we could put a potentiometer as well and sort of scroll it up or down to get the exact point with the light value, okay? But you can see it doesn't take a lot of coverage for somebody to activate that circuit there. So there's our first lesson on analog pins with a servo and an LDR. And like I said, I was going to give you some ideas about projects. That would work well with this, where the rocket moves behind that, and it's about fireworks safety for children, okay? Just an idea. Like I said, you could go into it, you could make this out of foam board or your acrylics, or bring the laser cutter and CAD cam into it and whatnot, okay? So the possibilities are your imagination. And I'll leave it there, and I'll see you in the next video.